Okay, guys, we wanted to draw this. Drew this graph here. What we want to do next is adding caption to it. So I have another graph here that has caption, and I will. Well, you need to put the TXZ picture inside this figure. So copy and paste, and also caption is inside the figure, but outside the TXZ picture. All right. Control V. Look, now I remove the TXZ picture here and substitute my own TXZ picture environment. I think it's very clear. I know at the beginning it sounds like, oh, what are we doing really, right? But actually we don't need that. We have it already. Oh, we don't have it. Okay. So I want up to this point I cut it because I don't want to have two graphs. I cut it and be ready. I like to use tab here. I use this. So everything sounds good. I don't like this here. I want to add indentation so later we can read them. No problem. You can see that TXZ is not also. I feel all of them should be. Because we are inside. Unfortunately, in LaTeX, we don't care that much about readability of the code. And be sure, if you don't put this stuff in a nice way, you lose your creativity. All right, caption, plot of the threshold. Let's see what is the change here. Right, so caption, plot of the threshold, label. What is the label? I don't like the label here. Okay. I should say sigma I theta, right? Dollar sign. We will edit them later. Sigma AI theta I for, I can say what was my okay, if you remember, we were drawing the graphs for two examples, one for Cornell and one for Bertrand. All right. want to look at the parameters. So it is Bertrand because R and T are positive for optimal revenue problem of wait. So for optimal revenue problem of the Bertrand example, know the example. By the way, let's look at Bertrand. Bertrand example 2.2 for Bertrand competition. All right. For Bertrand when the firms are assumed to be obedient and what is wrong with my obedient? Alright. For what are the parameters? R is 1/16. Let's check it here too. N is 5. Where am I? Okay, for R. N is 5 R 16 T is 1/2 2 S1. What else? Mu theta I. Is 2 mu omega is 12. Something happened. Mu omega sigma theta I squared is 2. And what is the last one? Is 2. As we can see, well, I want to say the benchmark has a unique solution. Well, it should have. Well, I want to give an explanation for the graph. What is it that we are learning from this graph? Let's say the degree 3 equation has a unique real solution. We may change it. I want to add something. So let's have it here. Probably we will discuss it and change it. And also, what's wrong with this? Fuck you. Well, it was working before. How does it change? I guess it's... What is the relax? It was working before, so it cannot... So... let me see. Oh. Okay, my caption is not closed. Is that it? Yep. And also I want to label it truthfulness without obedience, TWO. TWO Bertrand. Bertrand. Right, let's see. Okay, sounds good. I don't want to spend more time on this. Let's go draw the figure for an where is it? Q positive R negative, which is a Cournot situation. Okay. It's just a copy and paste, guys. And we will change the label to Cournot, and here let's go look at our corner example. S is 1, T is minus 1. S is 1, T is minus 1. And R, what about R? R is, what the fuck? T is minus 1 in kernel, so what is R, by the way? R should be something negative. So actually, what is R in, okay, in kernel, R and T are both positive. In, did I say Bertrand or kernel? In Bertrand, R and T are both positive. In kernel, R and T are both negative. So, because they are the same, they have the same sign, there is no point having a graph for kernel or having a graph for Bertrand. Let's see if beauty contest gives us a new one. No, in beauty contest also R and T are the same sign. A situation where R and T are, oh my god, different signs, we don't have it. Let's go, instead of getting upset by this fact. So we want a situation where R is negative, T stays positive. One, I think R should be, what is the interval allowed for R? I think -1/2 works, but let's make sure of this fact. I should get rid of all of these big equations here. It will be our next step. Where is it? Yep. And the first solution minus R, I will say let's put it -1/4. Let's see how it goes. It cannot be kernel anymore. Where is n figure? Here. TWO, but I want to different signs. Neg RT, I will write it that. Neg RT, negative RT, and also for optimal revenue, okay, I will repeat. It was just randomly happened. Neg stands for negative. There is a complete space here, and RT is the product of R and T, and it is negative. That's it. Alright, I didn't mean anything. Alright, so for optimal revenue problem of for the optimal revenue problem when assume to obedient. Wait, why is it like that? Okay, alright. And dollar sign R T less than 0 for n R. Why is R 16? It's 1 over 16. Frac minus 1. For and our T, what is the T? T is 1. T is 1. And yes, is 1. Oh my god. Oh, we chose T 1/2 in the other example so that C T sigma theta I squared be 1, or we chose sigma theta I squared as 1. So let's choose this one. 1. Where is you should sigma theta squared is capital D. I will choose it to be 1. T is 1. N is 5. Is that it, or there is more to say? Okay, it's here. You can see it is more narrow. I say the graph looks good. Everything looks fine. I don't think there's any point comparing this graph to the other graph. That's it. Well, we can also change the range of x-axis and y-axis, but I like the look here. It doesn't look very bad, or the graphs are not too small. So let's keep it like that. Sigma I theta I for optimal revenue problem when the firms assumed to be obedient, and RT is negative for N5. That's it. Okay, we added the captions. Now it's the time for how long is it? I don't know. Oh, okay, it's here. 25 minutes. All right. Um, Now let's check this part. Uh, 6.3, expanding out the conditional expectation. Well, this is the formula for pi of theta I. There is no escape from it, it's just a big formula. Alright. And then expected pay then. I could say we can have this right away and leave all of these big formulas probably in the appendix, or it is just because it is basic math. We can say we can compute expected payment using proposition 6.3 and get rid of all of this. Really, well, at the time when I was computing it, it was necessary to have this. It is kind of a scratch paper writing. And then for symmetric mechanism, I can even jump into here. It is basic math, we don't need to prove them, and simple enough. I mean, basic is not basic math. It's like any person who had a course in mathematics in undergrad level, knows integrals, knows differentiation, can do that. Individual rationality requires this. Well, this line is good. Therefore, and I can again simplify that. I don't need the whole formula there. Right? I don't need it. I can say that, dude, this is it. We have a formula for payment. We can compute this, and then okay, why do we use individual rationality? Individual rationality is to give us the constant of payment. I can say using individual rationality and substituting the formulas we already have, we can say like all of these are bullshit. Okay, this part is important. Wait, because how I do it is like I bring pi mu theta I into an inequality by moving the terms from left hand side of the inequality and right hand side. So at the end I have this inequality, which is pi mu theta I less than this f theta I, which is a quadratic function of theta I, and I want to say pi of mu theta I should be, maximum amount should be less than the minimum amount of this, right? Can I even say it's a quadratic function? Then these are these are pure scratch paper stuff. So we don't even need them. By one if false, because we will comment them out for sure. And now we have this. This will be expected payment. I like to keep that here. and then we will say that it is this, and this is our optimal problem. One thing I have to mention is that we have for this benchmark, because mu's are not the same with the optimal revenue problem and first best. We came to this conclusion that there is no point comparing sigmas, or they are not the main part. The main part is comparing mu's, and we can do that. So we want to compare mu AIs. And what is mu AI here, by the way? Do we have it? Oh, we have it. Yeah, we have it in the optimization problem. Here, where is it? Okay, up to here still we have mu AI. Then it's here when we choose optimal mu AI as disk ratio. And I want to compare this. The rest for computing optimal sigma AI theta I really is just to show that we proved something. There is this solution, but to be honest, we don't. At least for now. Maybe if we have more conversation, we can say some stuff. We didn't talk about this solution to all of our collaborators, so maybe they have some points, but based on my talk with Thibaut, there is nothing much we can say about. So these all go to oh my god, my hip hurts, dude. Oh guys, I was at kickboxing yesterday and we were side kicking. I was not kicking anybody, it was just kicking the air, shadow kicking, and I stretched my leg too much. Well, I have to do a stretch regularly. Regularly I have to do a stretch, and I don't do it, and that's what happens. That's what happens when you don't have a flexible body. You punch and you kick, and I think I'm fucked. Now I cannot do probably squats, I cannot do anything in the gym for a while. I'm so stupid, guys. Do stretch, I guess. Put on your Pamela Rife, do the stretch. What is it I want to say? Okay, before editing, let's go and see how Thibaut added this part. Look at how smooth it is. Like all the lines, there's one small line and there is some explanation. We want to have something like that, right? Right. When the reader it's not just mathematics, it's explanation and then one line, every line. There is no big equation here. Even in the proof, look at his proof. But what I am looking for right now is not the how you're these one-liners, but it's more. He did it in a different way. The computations, and it got much simpler. Instead of writing, because there is a relation between pi of theta and mu I, and I did it the first way that comes to your mind, just writing everything based on equations, usually end up being messy. But he did it in a smarter way. I'm looking to find. Okay, about smarter way, by the way, it's just, I'm quoting from Thibaut. When we were talking, he said, like, yeah, now I can write it in the smarter way because you had the computations, we had a better understanding. So you don't need to start writing stuff smart. Maybe you start dumb and simple, and then you have a solution and say, oh, there are too many terms here are canceling out each other. So there is probably smarter way to do the computations. But if you go really through the process, sometimes you do it the dumb way, brute force, and then at the end, what you want to show to the reader is just the cleanest format, easy to read. But we will go over this text over and over. So let me find his email. Okay. Yeah, we have too many people. We have too many people. We have too many emails. I don't know which one it is. No. Meeting. Adding to the notes. ASAP. These are October. October is too old. Okay, we have one Christmas, so yes. Fuck that, it's not here. Again, truthfulness, no obedience. Nope. Another paper. There are emails that other people are also in it, but in the middle of them, I think there are emails just between me and Thibaut. I say fuck that. Let's clean up. Oh my god, my leg hurts. Do the stretch, guys. Oh shit, I'm dying. Alright. Yeah, let's go over the part. I think I can find it here actually. It should be here. Yeah, here. Yes, here. Look, it's here. Where he simplifies by saying that, okay, this Vi and Pi prime are related. Let's read this part. Hmm. 3.9 okay. Well, this is the same. What is six sections? Section 6.3 and section 6.4, they're the same. Also, we want to change every sigma I theta I to as this ratio, and probably sigma AI omega to sigma AI omega over S sigma omega squared. Okay, so we already have this, right? Or it's different? Wait, if the outside option, what is this outside option here? So I can remove all those parts. Yep. Oh, thanks God. Alright, let's go over it because this text is fully related to the other one. What is proposition 3.9? So, assuming that they are following the action recommendation at the second stage. The mechanism is truthful if only if covariance this and the derivative of the payment function is given by this. This is how he writes everything nice and clean using this formula. So let's learn this shit. Spence Mireles. So, okay, participation constraint matters to me. I want participation constraint so people in their outside option should act the same way that they are playing in the main path, right? So in outside option, the participating players, they are participating players in the game in the outside option. When one of them decides not to participate, n minus one of them decide to participate, the n minus one will receive a mechanism where the mechanism is designed in a way that it is truthful, but we are assuming that the n minus one player will follow the recommendation. So there is no obedience for them. So if it is the same participation, we are good to go. And if it is not, we have to come up with our own. Because Thibaut was also working on the situation where in the off path, the n minus one players can actually, you can set the utility of the is it their action or what was the off path? Off path was setting the utility of the non-participant or setting the action of the participant. Because by setting the action of the participant one, it is the thing we have here. The reservation utility. So when it says which the players follow their action recommendation, it means that we don't have obedience constraint. We assume players are obedient. So that's a good, because we have instead of saying without obedience, we can say truthful mechanism in which the players follow their action recommendation. From now on, whenever we say it, we want to say truthfulness without obedience, at least in the text, maybe it's a good choice of. It's a good sentence because it's also, I want to keep it the same so that the reader knows, okay, this is the same situation. Instead of saying like, I want it to be like a title and be repeated. Exactly the same order. I don't want to have another sentence that makes the same sense because I want the reader to know that we are talking about the same subject. Truthful mechanism in which the players follow their action recommendation. Actually, okay, the thing I told that we had two off-path choices, it doesn't change here. That thing I mentioned, two off-path choices were it was something we were thinking about for the main problem. In the main problem where all the players are also rational in following are free to follow the action recommendation or not, we have to add the obedience constraint. And Alessandro was saying if we can assume in the off path when one of the firms decide not to participate, the other firms will follow the action recommendation. And Timo and I still are not okay with this choice. So for this benchmark, the only outside option, the remaining firms will follow the recommended action. So what is this G function? What is this G function? For some constant Ci, G is upper bound. What is G? So, okay, G is not something we know. G is something he defined as a dummy function or something to help the writing person. So if G is upper bounded and the payment is this. Ci should be greater than or equal supremum of g of theta I. Well, okay. Let's move on. In particular, the maximum expected payment that can be collected from player I, implementing the recommendation rule in a truthful and individual rational manner is this. So, okay, this is it. Truthful and individual rational, so no obedience. What was G? It should be why should it be the case? We want ui minus pi minus uio. Okay. And when we do the minusation, we have 2t mu theta I to theta expected ds. Right? uio is g plus t integral. uio is g plus t integral. ui minus pi minus uio is ui minus pi minus g minus the t integrals go away, ci minus, okay, so ci minus g theta I should be greater than or equal 0, then ci should be greater than or equal supremum of R. Makes sense? Which requires in particular that g be upper bounded. Alright, good. Well, what is g, by the way? Okay, that's the function. And we have uio, we have expected of ai as the function. So we are good. Oh my god! The claim about the maximum collectible expected payment easily follows from expectation of this integral is on, yep. Okay, what was the what is it from? So okay. The loss of revenue to the seller due to having to satisfy IR and truthfulness is paid. It is what is it? Gi theta minus supreme. Why is that? ui minus pi minus uio. Okay, that's it. Oh, my fucking leg is oh my god. Dude. You know, I think I had this injury 2 years ago or 3 years ago. I don't remember. And after going to physical therapy for a year, I was super cautious. And then you say, okay, it seems I'm good. And you start forgetting and getting more arrogant. But to be honest, I didn't expect it to happen from a sidekick. And obviously it was because I didn't do the stretch. Especially when you do deadlift and you do leg day and you don't stretch after them, all your muscles are tight and you want to suddenly kick. Well, I say that at the beginning of the kickboxing session, I was stretching, but it was not enough. So whenever I was kicking, I was like my leg used to bend right away. It couldn't go and keep it right at the end. And the coach said, okay, I want you to stick it out and hold it. And I did it. First time I did it, I kicked powerfully. So fuck my hip. But if I did it slow, I could probably do it. And when I kick, it's like this actually. I cannot open my leg at all. It's like I am standing. Anyways, I think I will do my physical therapy exercises again, but I hope this time it just gets good right away. I don't want to spend a lot of time again being away from squat rack. Okay, let's give it 15 more minutes. Were we here? Yes. So we don't use this one as our off path because it is assumed that players are obedient, required to obedient mechanism for which the mechanism used off path mechanism is required to be obedient. So in this section, Thibaut did a great job. He gathered all the off-path situation where the players are either obedient or will follow the recommendation anyway, and said, okay, there is a common strategy for both that works to give us the constant in the payment. This is the part I'm interested in. This is the part, the benchmark I'm working on. Maximum penalty mechanism. It also has a name. Okay. That's it. Okay, guys, I have to stay awake. That is, we need to solve this. And this is a convex quadratic function m whose minimum is obtained at m star, and this is it. That's it. We instantiate proposition 6.4 with the maximum penalty mechanism. We obtain maximum penalty. Let mu k be recommendation rule. Layer follow the recommendation, and that the off-pass mechanism chosen to be maximum penalty mechanism. Then the recommendation rule is implementable in a truthful and individual rational manner if this, the mechanism collectible payment is this, which is the same payment I have, right? Fuck. I don't want to show you. Okay, I know how to do it. to look at my formula. For symmetric ones. Wait, where is the okay, it's this. So a lot of the steps that I should have taken, now it's already taken. So I can say this is the expected payment, and right away I can say that based on corollary 6.7, we have expected payment for maximum penalty mechanism, and this is it, and I will compute the rest. Right? So he also computed expected utility, and that's it. That's actually most of the job is done. Oh. I cannot wear my shoes, to be honest. I'm not wearing shoes, but I couldn't wear my socks today. Okay, so we have everything, right? These two are the same. N minus 1 mu AI squared mu AI squared then this shed which even looks better with this ratio. Is it the same though? Yep, it is the same. Plus mu AI. That's it. Minus where is it? Plus t. Yep. Plus minus 1/2 sigma squared. Minus 1/2 sigma. N minus 1 r sigma AIJ. And well, N minus 1 r sigma AIJ. Where is it? S sigma AI omega. S sigma AI. So okay, everything we have already. So all of this I can remove them. I can remove all of them. I can remove even here. So that's the rest. And the proof is here. I should work on the proof. So let's go at the beginning of the section. Actually, so once again, let me repeat, I did all of these long computations, but it really helped, like doing these computations and seeing that a lot of terms in these big equations will cancel out, helped us to see that okay, we can write the formulas in a smarter manner. So it was not from the beginning we were writing it very smart. I wanted here. Yep, here. And also this part should go to the proof. God knows how long. How can I find the do you think I went too far? No, whenever I see this, what did I do? What did I do? Okay. Thanks. Oh, I want to, okay, what am I doing? I put the false, I put the fee. I just want to do the indentation. Really doesn't matter now. But it's good. Where did I put it, by the way? Okay, it's here. And if false is here. Maximum penalty. Well, the name of the benchmark should stay the same. Maximum penalty is just for the outside option. Anyhow. Oh, what is the line number? I can find it this way. It is 628. 628. And it was 460. That's it. Let me also add this. Okay. I say that's enough for now. The rest of, well, I was very lucky, honestly. Just a lot of editing part was done by Thibaut already. The next part is just the proof. I say this is the optimization problem, and put this stuff in a proof, and then I also add another remark or proposition that says that compares first best this benchmark and the optimal revenue in their mean. Probably next time. Alright, thank you. And I also should email Thibaut. For a meeting.